All right, we're going to keep working with our triangles. I can use isosceles and equilateral triangles. So if you look at kind of your notes here, if two sides of a triangle are congruent, then the angles opposite them are congruent. So notice that this side is congruent to this side right here, which means the angles opposite or almost like across from them. So that's this angle right here and this angle right here. So if you have two sides that are congruent, you have to look across from those sides to find the congruent angles. So again, I see that, hey, I've got congruent sides right here, which means this angle and this angle are congruent. So if I were to write this down, I would say, well, angle DFE is congruent to angle DEF because their sides are congruent. These sides are congruent, which means the angles opposite or across from them are congruent. So if I look at this example, if HG, so segment HG, is congruent to segment HK, again, that dash means congruent, then this angle is congruent to this angle. So then I'll say angle K, again, we want to use 3 letters to be as accurate as possible. HKG is congruent to HGK. Remember, the middle letter is our angle, and then the two outside is what's sandwiching it. If angle KHJ is congruent to KJH, so KHJ, so that's this angle right here, is congruent to KJH right here, then again, opposite of the angles is what's congruent. So this length is going to be congruent to this length. So I will say then segment HK is congruent to segment KJ. All right. So again, looking here, opposite, that means that this side is the same as this side. And so if these two sides are the same, I better set them equal to each other. X equals 6. Equilateral triangles are very similar, but instead of just having two sides that are the same, you have 3 sides that are the same. So we're going to do a lot of the same types of ideas, but with all 3 sides. So Y is really easy, because if this side is 4 and all 3 sides are the same, this side's going to equal 4. And if this side equals 4, this side equals 4. So now I have to think, okay, I've got opposite across. Okay, 4 equals x plus 1, which means that x equals 3. Okay, let's keep going. Again, opposite across, opposite across, opposite across, opposite across. Okay, so let's see, what do we got to work with here? We know that this angle is 2y plus 64. This top angle is 50. And we can say that this angle is also 2y plus 64 because they are the same. So I'm going to set these two, I'm going to add them all up, because remember, triangles always have 180 degrees. So 2y plus 64 plus 2y plus 64 plus 50 equals 180. 64 plus 64 plus 50 is 178. So I get 4y plus 178 equals 180. Take that away, 4y equals 2. Divide by 4. So y equals 1/2. So if I plugged in y for 1/2 right here, again, 2 times 1/2 plus 64, that's 1 plus 64. So this angle is really 65. And these two angles, because they're adjacent and they form a straight line, mean that they are going to be a linear pair. So I can say, well, if that angle is 65, then this angle is going to be 125 degrees. So again, it's going to be very similar. I've got I have two angles that are the same, and I know that this third angle is 125. So 45 minus x over 4 plus 45 minus x over 4 plus 125 equals 180. Combine some like terms, 45 plus 125 is 215, and negative x over 4 plus negative x over 4 is negative 2x over 4. We can simplify that. Plus 215 equals 180. 180 minus 215 is negative 35. So we get negative 2x over 4 equals negative 35. Again, that's like saying negative 1/2. I can reduce this. So let's see here. I'm going to move over here. Negative 1/2 x equals negative 35. So multiply by 2. And when I multiply by negative 2, I get x equals 70. So y equals 1/2 and x equals 70.